All right. Good afternoon. Any question before we start? So the due date for the homework will be tomorrow, 3 p.m. So, um, so let's continue on velocity analysis. What we did yesterday, we started working on offset slider crank. To do velocity analysis, first we need to do displacement analysis. So for doing the displacement analysis, the constants are the length of the links and the offset. Variables are two angles and one displacement, which is S or D, depending on the variable that you want to choose. And you solve for the nouns would be constant plus one of these two variables, which in this case is theta 2, input angle is given. We are solving for theta 3 and S. This displacement and the angle of link 3 or link 3. When you go to the velocity analysis after you are done with displacement, the constant would be the same. The variables would be derivative of the variables that you had on displacement analysis. So here we had theta 3, so just differentiate that with respect to time. It's gonna be omega 3 or theta dot 3. I usually use theta 3 dot to label denotes the omega 3 or angular velocity of link 3. And S, its derivative with respect to time is gonna be S over dt or S dot. And the last one would be theta dot 2, which is the angular velocity of link 2. So what would be the nouns? The nouns would be constant that we have right here, plus the information that we get from displacement analysis, which is theta 2, theta 3, and S. So we should know these three as well. And whatever is noun here, its derivative should be noun right here. So theta 2 is given, so theta dot 2 or omega 2 should be given. And you are solving for the theta dot 3 and S dot, which are the derivative of these two unknowns on displacement analysis. So this is basically what we covered yesterday. We started from displacement loop vector equation, then we differentiate with respect to time. So we apply chain rule. We know that if we have cosine of theta 2, if you want to find its derivative with respect to time, since the t and theta 2 are not the same, but theta 2 is varying with time, we should use the chain rule. So this is the chain rule. Instead of using dt, I'm using the cosine of theta 2 over d theta 2 times d theta 2 over del t. So derivative of this with respect to theta 2 is going to be negative sine of theta 2. Derivative of theta 2 with respect to time is going to be omega 2 or theta dot 2, or how fast angle of theta 2 is varying with time. The constant and the coefficient we don't differentiate. D or S is varying, so if we differentiate that, we can get these two equations. We derived this equation yesterday, so I'm just having a quick review. So if you summarize the equation, you will get these two equations. D or S dot minus, let me use D dot if you want. D dot minus B theta dot 3 sine of theta 3 equals to negative A theta dot 2 sine of theta 2. And second equation would be b theta dot 3 cosine of theta 3 equals to a theta dot 2 cosine of theta 2. Two equations, we are solving for d dot and theta dot 3. In matrix form, the equation can be written as this. So we are going to define three matrix, matrix A, matrix X equals to matrix B. Matrix A is going to be the coefficient. It's going to have 4 terms, 2 by 2. Matrix X would be our variable, which are d dot and theta dot 3. You can first write, you can have theta dot 3 up, d dot here, or vice versa. So, and C is going to be the constant matrix, which is 2 by 1. 2 rows, 1 column. So first row is representing the first equation. What would be the coefficient of first variable in first equation? 1. Just plug in 1. What would be the coefficient of theta dot 3 on this first equation? Negative b sine of theta 3. And constant part is going to be this. Similarly, I can fill out the second row with the coefficient of d dot equals to 0. There is no d dot on the second equation. And coefficient of theta dot 3 is b cosine of theta 3. Right here. B cosine of theta 3. And constant part is going to be this. Then you can use the MATLAB to solve the problem. We solved one example yesterday. So before I go through the next mechanism, let me ask you this question. If I tell you that theta dot 2 is constant, suppose it's 3 radian per second. So you have a motor which is running at this constant speed attached to link A, and it's running the mechanism at the constant speed. Can I say that theta dot 3 and d dot would be constant for different angles at different angles of theta 2? The mechanism is running and theta 2 is varying when the mechanism is moving. So can I say that if theta dot 2 is constant, I should get d dot and theta dot 3 constant values? No, why not?
Because even though that one's going the same speed, at some point it's going to reach its further, like the slider will be its farthest, and when it continues going around, it's going to quick jerk the other and still traveling the other way. And that's the change, so it's accelerating.
Mechanically, you are right. They are not constant, and mathematically, if you want to find d dot and theta 3, you should solve this system of equation. You know that theta dot 2 is constant, so this is constant for different value of theta 2. But theta 2 is varying. At the same time, theta 3 also is varying. So you will get two different matrices for matrix A and B. So although omega 2 is constant, the speed of slider and angular velocity of link 3 is not going to be constant. So you are going to have variable speed for slider and link 3. Good? So the mechanism is running at the constant speed, but the speed of link 3, angular speed of link 3, and the slider is not going to be constant at different angle of theta 2. Any questions so far? All right. Let's move on. 4-bar mechanism. we would like to do velocity analysis for a 4-bar mechanism. So to do displacement analysis, we know that A, B, C, and D are constant. The variables are theta 2, theta 3, and theta 4. And the nouns would be constants plus theta 2 because degree of freedom is 1. We are solving for theta 3 and theta 4. This is what we have done for displacement analysis. For velocity analysis, constant would be the same, A, B, C, and D. The variables, whatever the variables are here, just add one dot on the top of each, which they represent angular velocity of link 2, link 3, and link 4. Omega 3, omega 4, and omega 2. So we would like to do velocity analysis with the unknowns constant plus theta 2, theta 3, theta 4 from displacement analysis plus whatever is known here, its derivative or its speed should be given. Then you are going to solve for the remaining variables, which are omega 3 and omega 4, or theta dot 3 and theta dot 4. So if I want to explain the velocity problem for 4-bar mechanism, we have a motor here, it's running at the speed of omega 2. What would be the angular velocity of link 3 and link 4 when this mechanism is at the angle of theta 2, theta 3, and theta 4? This is what we want to do. Again, everything is going to start from vector loop. O to A plus AB. I should stop here because two vectors ending at point B equals to O to O4 plus O4B. X component would be A cosine of theta 2 plus B cosine of theta 3 equals to B plus C cosine of theta 4. And Y component would be A sine of theta 2, B sine of theta 3. B doesn't have any X component. 0 plus C sine of theta 4. This is X and Y component of vector loop equation. Since for velocity analysis you need to derive the velocity equation by differentiating the X component and Y component, I just want to make sure that you know how to differentiate the equations. So find me the X component and Y component of velocity equation. So just differentiate both sides with respect to time. Then I ask you about it. don't see. No. Number 21. Would you write the first equation?
Anyone?
Over there, on the top. Would you tell me what would be the variables in this equation? What we are looking for?
Looking for
Thank you. Yes, that was the only part that we needed to divide. So when you differentiate the first term, a is constant, derivative of cosine is gonna be derivative of cosine with respect to theta 2, which is gonna be negative sign, times derivative of theta 2 with respect to time, which is theta dot 2 or omega 2. So it's not theta 2, it's theta dot 2. Everybody can see how we drive this equation, because when we go to the other mechanisms, you are supposed to know how to differentiate the velocity equation from displacement.
should the second term be minus b?
Yes, I didn't say it. Yes, it should be negative. Both are negative. Any question on this? So I will write the second equation. A sine of theta 2, derivative of that is going to be A cosine of theta 2, A theta dot 2 cosine of theta 2 plus B theta dot 3 cosine of theta 3 equals to 0, doesn't have any differentiate. So it's got to be plus C theta dot 4 cosine of theta 4. We get these two equations. The unknowns are theta dot 3 and theta dot 4. I move the terms which they have theta dot 3 and theta dot 4 one side. I keep the other terms which are constant in one side. So it's gonna be B theta dot 3 sine of theta 3 minus C theta dot 4 sine of theta 4 equals to negative A theta dot 2 sine of theta 2. And second equation is going to be negative theta dot 3 cosine of theta 3 plus C theta dot 4 cosine of theta 4 equals to A theta dot 2 cosine of theta 2. Basically the first term here is negative, second term is positive, and the other side is positive there. I have positive, negative, negative. So if you multiply both sides by a negative, you will get the same thing. Let me do that. And second equation, just multiply one negative. I just want to have the same equation, but it's not going to change it. So these are two equations. We are done by deriving them. But if you want to write the matrix form again, we are going to have two matrices: matrix A, matrix X, matrix C, C, X, A. And matrix X, you should write your unknowns, which are theta dot 3 and theta dot 4. You can either first write theta dot 4 and then theta dot 3, or vice versa. So it's first row is for first equation, second row is for second equation. First row, what would be the coefficient of theta dot 3? Negative b sine of theta 3. The coefficient of theta dot 4 is positive c sine of theta 4, just this. And right side is constant, is going to be a theta dot 2 sine of theta 2. Second equation, the coefficient of theta dot 3 is b cosine of theta 3. Negative c cosine of theta 4, and right side is negative a theta dot 2 cosine of theta 2. On MATLAB or your calculator, you just enter matrix A and matrix B and solve for x. I will show you in MATLAB shortly, but any questions so far? All right, let's do this example. For a mechanism with the length of 3 for A, 6 for B, and 5 for C, and 10 for D, if the input link has the angular velocity or angular speed of 10 radian per second, at angle of 57, when the input link is at the angle of 57, we would like to do velocity analysis. So we would like to find omega 3 and omega 4 when theta 2, theta 3, and theta 4 and omega 2 are given. How do we know theta 3 and theta 4? For this input angle, you can do displacement analysis and find theta 3.1 equals to 16.85 and theta 4.1 equals to 121.66. Let me see if I have the second. No, I don't. So there is another mode for that. I don't have the information for that, but it should be something here and something there. If you solve it. So here I didn't say it's clockwise or counterclockwise. If I don't say if it's positive means counterclockwise. So means this link at the angle of 57, it's moving this side. So when it's moving this side, we would like to find the angular speed of theta 3 and theta 4. Just we plug in the number. B is 6. Theta 3 is given. C is 5. Theta 4 is 121.66. Second row, you plug in there, and you will find this matrix 2 by 2. Right side, you have A, which is 3. Theta dot 2, it's positive 10 because we didn't say it's counterclockwise or clockwise, but it's positive as a given. So we plug in there, we will find these two. How can we find omega 3 and omega 4 in MATLAB? I showed you yesterday, but I'm gonna do it again. You just enter matrix A, which was negative 1.739, 4.256, 5.724, 42, and 2.624. And matrix C is 25.16 and negative 16.34. Negative 1.739 space, enter second number 4.256, semicolon brings you to the second line, 5.2556 space, you don't need a space here, but one space there, 2.624. This is matrix A. Matrix B is 25.16. Semicolon, it goes to the second line, negative 16.34. Now you have A and B. The command that you should use is A / B. A / B. It's gonna give you two values. First value is for theta dot 3, second value is for theta dot 4. So you can report theta dot 3 at negative 5.033, omega 4 3.855. If I ask you, is it moving counterclockwise or clockwise? Since it's negative means this thing is moving clockwise at this angle. Then this is at 57 and the angular velocity is 10 for input angle. For input link, this link is moving clockwise with this speed. And link 4 is moving in this direction because it's positive with this speed. And the speed has a unit of radian per second. You might say, why don't we multiply inverse of A by B to get this result? You can do that, but it's much easier to use this command, A / B. But you are right. If you multiply both sides by inverse of A, here you will get I matrix. Right there you will get A inverse times C. You will find X value. The result shouldn't be different. Make sure that you know how to use this command because of the homework you need to use for MATLAB code. Question. Alright. Let's move to, and as you see, the difference between displacement analysis and velocity analysis equation are, in velocity analysis we have linear equations. The equations are linear with respect to their unknowns, but in displacement analysis for a four-bar mechanism we had non-linearity in system of equation. We had to apply tangent of half angle to solve the system of equation, but here we have linear equation in velocity analysis. I used to cover graphical approach for velocity analysis, but I'm not covering that this semester. So if you see on the slides, this page, these are for graphical approach. You're just playing with the vectors in the graphical ways to find velocity analysis. So the last standard form of the matrix that we cover, of the mechanism that we cover in the class to drive the velocity equation would be inverted slider equation mechanism. If we have inverted slider crank, this angle is fixed, is gamma, from ground line, this line is parallel to ground line. This angle is theta 4. This angle is theta 3. The angle of this link 3 with the ground. And this is a theta 4 angle of this link with the ground. These two are the same. This is A, this is B, this is C, and this is D. In displacement analysis, A was constant, C is constant, D is constant, and gamma is constant. This angle is constant. B is varying because the location of the slider is moving. Variables are theta 2, D, and theta 3, and theta 4. The nouns would be constants, whatever constants up there, plus theta 2. The input angle, and we are solving for B, theta 3, and theta 4. We learned that theta 3 and theta 4 are dependent. As you see, theta 3 is theta 4 plus gamma. So these two are dependent. We can solve two equations for two unknowns, find B and theta 4. On velocity analysis, the constant would be the same, AC, D, and gamma. Variables, whatever variables are there, just put a dot on top of that. Theta dot 2, B dot, theta dot 3, and theta dot 4. Omega 2, omega 3, omega 4, and the speed of slider. How fast this slider, this length is varying with time. and constant plus whatever we find here, theta 2, b, theta 3, theta 4, plus we have theta 2, we should be given with omega 2 or theta dot 2, and we solve for the remaining. Again, we got 3 unknowns, but we know that we expect to get 2 equations from velocity equation. What would be the relation between omega 3 and omega 4? Theta 3 equals to theta 4 plus gamma. So you are saying that omega 3 is omega 4 plus gamma dot is 0. Gamma is constant. So its derivative with respect to time is 0. So basically, I don't have, I just have one of them. The other one is going to be equals to omega 3 equals to omega 4. It's coming from this equation. Just differentiate both sides. So if I write the vector loop equation, I can write O to A equals to O to O4 plus O4B plus BA. X component would be A cosine of theta 2, A cosine of theta 2 equals to B plus C cosine of theta 4 plus B cosine of theta 3. And A sine of theta 2 equals to C sine of theta 4 plus B sine of theta 3. I replace theta 3 by theta 4 plus gamma. A sine of theta 2 equals to C sine of theta 4 plus B sine of theta 4 plus gamma. These are x and y components of vector loop equation. I just need to differentiate both sides. The first one, theta 2 is varying with time, its derivative would be negative A, theta dot 2 sine of theta 2. D is not varying with time, 0. C is constant, cosine of theta 2. Negative C, theta dot 4 sine of theta 4. So the tricky part is this one. B cosine of theta 4 plus gamma. Derivative of this with respect to time. B is varying, theta 4 is varying. So if you want to differentiate this, you should write something like this. Derivative of the first term with respect to time times the second term plus derivative of the second term with respect to time times the first term. make sure that you know how to write this term because you may need that to derive for some other mechanism. So derivative of two variables which they have multiplication, it's going to be derivative of first one times second one, derivative of second one times the first one. dv over dt, it's going to be b dot. B dot cosine of theta 4 plus gamma plus b times derivative of this. It's not varying, theta 4 is not a function of t, so we should use the chain rule. Derivative of this with respect to d theta times derivative of theta 4 with respect to time. So derivative of cosine of theta 4 plus gamma with respect to time, it's going to be derivative of cosine of theta 4 plus gamma with respect to theta 4 this part is going to be negative sine of theta 4 plus gamma. This part is theta dot 4. So I'm just replacing this here. So back to previous page. Just look at the first, this line. Negative a omega 2 sine of theta 2 equals to 0 minus c omega 4 sine of theta 4 plus this part b dot cosine of theta 3, which is theta 4 plus gamma, minus b theta dot 3, which is equal to theta dot 4 sine of theta 4 plus gamma, which is theta 3. It's going to be this equation second equation. If you differentiate this with respect to time, you will get a omega 2 cosine of theta 2 equals to c omega 4 cosine of theta 4 plus b is varying, so its derivative is going to be b dot sine of theta 4 plus gamma. Theta 4 is varying, so plus b theta dot 4 cosine of theta 4 plus gamma. Equation 1, equation 2. B dot theta dot 4 would be variable. We should keep them in one side. We move the other term to the other side. For the first equation, I should keep this 3. And I have the constant part on the other side. Second equation also, I don't need to touch the second equation as well. This is matrix X, which are variable. Variable are b dot and theta dot 4. You can either write b dot top and theta dot 4 right here, or vice versa. On the first equation, just first equation, what would be the coefficient of b dot, which is our first variable? It's cosine of theta 4 plus gamma, which is theta 3 as well. The coefficient of theta dot 4. I have this c sine of theta 4. I have this negative b sine of theta 4 plus gamma. So I have summation of these two. Negative c sine of theta 4, negative b sine of theta 4 plus gamma. On right hand side, it's constant negative a theta dot 2 sine of theta 2. Second equation, the coefficient of b dot, is sine of theta 4 plus gamma or theta 3, and coefficient of theta dot 4 is c cosine of theta 4 plus b cosine of theta 4 plus gamma, and right hand side will be this guy. Now you can solve this system equation by your calculator for one time. I posted the homeworks, which is 2 weeks from now. But since we have exam on Monday, don't ask me to just extend the due date. So I just posted today, 2 weeks past.